Hello students, today we are going to start a new chapter, that is atoms and molecules. In this chapter we will be talking about the atoms and as well as we will be discussing about the molecules. In this chapter we are going to talk about the laws of chemical combinations, and under the two laws of chemical combination, the first one we will be talking about is law of conservation of mass, and the second law we will be talking about the law of constant proportions. So we will be studying these two laws in detail in this chapter. Under the laws of chemical combination, first study about the law of conservation of mass. According to this law, it states that mass can neither be created nor destroyed in a chemical reaction. So there would be no changes in the mass. It can neither be created or nor it can be destroyed in a chemical reaction. So what does this mean? It means that during a chemical reaction, the sum of the masses of reactants and products remains unchanged. That means whatever the reactant mass would be there, it would be same as the product. So to prove this law, they have done one activity. For example, they have taken the sodium sulfate solution in a conical flask. Okay, this is the conical flask in which they have taken the sodium sulfate solution. Okay, and some barium chloride solution in an ignition tube. Inside this there is an ignition tube, and inside it contains the barium chloride. But the barium chloride, it is hanged. Okay, the ignition tube was hanged in the flask by a thread and poured a cork on the flask, and after that it was covered with this one cork. The conical flask was covered with a cork. Then what we did, we have to find out the mass. What was the mass of these two, the sodium sulfate solution and as well as the barium chloride? So what it came, it was 300.23 gram. Okay, so the first initial measurement was 300.23 gram. Then after that what it did, then they tilted the flask, and when they tilted in this way, what happened? The chemical reaction took place. Why? Because the barium chloride, it got mixed with the sodium sulfate solution. Okay, and with the reaction of these two, a new product was formed. Okay, and when there was the new product, barium sulfate, can you see here the white precipitate barium sulfate, new product was formed, and again the mass of the flask was observed, and when they observed the mass of the flask, it remained unchanged. So you can see when the reactants were differently kept in the ignition tube and as well as the flask, the mass was 300.23 kg, and when both of them got reacted and formed a new product, then also the mass was same, that is 300.23 gram. So this law states that the mass can neither be created nor destroyed in a chemical reaction. So here also they have taken again the same kind of experiment with different kinds of reactants. Can you see this here? Instead of barium chloride, they have used the calcium chloride. Okay, and here also sodium sulfate is there, and after that when both of them were tilted and a new reaction was formed, there also the mass was same between the reactants and the products. So here also the same mass and here also the same mass. So the reactant was calcium chloride solution and sodium sulfate solution, and the product formed was calcium sulfate with white precipitate, and along with it sodium chloride solution was also found. Even though there was the formation of new products, but the mass was same in the reactant as well as the product. So you can see here same thing, and you can also say that during a chemical reaction, the sum of the masses of the reactants, that means the sum of the masses of the reactant is equals to the product. So what you can see is equals to the product. For example, 71 gram plus 2, it will be 73 gram. So product formed will also be 73 gram. So what does it mean? The mass of the product remains equals to the mass of the reactant. So next one is the law of constant proportions. And in this, what does it say? In a chemical compound, the elements are always present in a definite proportion by mass. Means whatever the compound is there, the element is present in a definite proportion. For example, they have taken the example of water. Water always contains the two elements of hydrogen and oxygen combined together in the ratio of 2:16 or 1:8 by mass. If 9 gram of water is decomposed, we get 1 gram of hydrogen and 8 gram of oxygen. So you can see the water always contains in this proportion. Okay, in the same way ammonia also 1 nitrogen and 3 hydrogen. This is the proportion of ammonia. And in the same way water, there is 1 oxygen and 2 hydrogen. These are the fixed proportions. So that is why it is called as the law of constant proportions. Some of the chemical compounds, they are present in a fixed proportion by mass. So here also you can see, also known as definite proportions also you can say. For example, in carbon dioxide. So there is 1 carbon atom and there will be 2 oxygen and it forms CO2. Okay, in the same way carbon monoxide, there will be 1 carbon and there will be 1 oxygen. So it will form carbon monoxide. These are the constant proportion, or you can say fixed proportions. Here also you can see, when you have to make the water, 2 atoms of hydrogen and 1 atoms of oxygen will give you 1 molecule of water. So these two are the hydrogen atoms, this is the oxygen atom, and when we combine these two, they form a compound H2O. H2 plus O will give H2O. That means they are present in a fixed proportions. So let's talk about the John Dalton. Okay, John Dalton was born in a poor weaver's family in 1766 in England, and he was a teacher in the beginning of his career, okay, at the age of 12, and after 7 years he became the school principal, and then he left for Manchester to teach mathematics, physics and chemistry in the college, and then most of his life he spent in teaching and researching. And in 1808 he presented the atomic theory, which was a turning point in the study of matter. So here also you can see what he said. He said that each element is composed of extremely small particles called atoms, and all the atoms of a given element are identical, but they differ from those of any other element. Then atoms can neither be created nor be destroyed, and after that a given compound always has the same relative numbers and kind of atoms. So these are the Dalton's atomic theory. You can see it in your NCERT books as well, and you can read it. So matter is made up of tiny particles, and he named it as atoms. Then atoms are indivisible. That means when he took out this theory, according to him, atoms were the smallest particles. Okay, so which cannot be created nor be destroyed in a chemical reaction. Then atoms of the given element are similar in mass and properties. For example, if similar kind of element is there, so they will have the similar mass. And then atoms of different elements have different mass. Then atoms combine in small whole number ratios to form the compounds. For example, H2O, H and O, they combine together to form the water. And in a given compound, the relative number and the kind of atoms are constant. Okay, so in a compound, the numbering of the element or the atom are constant. So this is how the Dalton's atomic theory was proposed by the Dalton. So that's it all for today. We will be discussing the further topics in our next video. Till then, bye bye everyone.